Okay guys, we're back with the factor theorem. And the factor theorem says that the binomial x minus a is a factor of a polynomial f of x if and only if f of a equals 0. So don't let the words confuse you. Look at what it's told you. If it's x minus a, then we're going to find f of a by substituting whatever basically your 0 is into your function, and if it equals 0, obviously it's a factor because it has a remainder if it's a factor. So example 3 says if x plus 1 is a factor, so they've already told me if it is a factor, or no, it's asking us, is it a factor of this polynomial? So if this is my factor, we're going to find f of a. So you're going to take your factor, basically, think about setting it equal to 0. So you would subtract that 1. So we're going to find f of negative 1. So f of negative 1 is what we're going to find. So if f of x is equal to this polynomial, we're going to substitute negative 1 everywhere we see x. So you're going to have 3 times negative 1 to the 4th minus 4 times negative 1 to the 3rd plus 12 times negative 1 squared plus 5. And then we're going to simplify. So any negative number to an even power is going to be positive. So that's going to be 3 times positive 1 would give us 3. A negative number to an odd power is negative. So negative 1 to the 3rd is going to be negative 1 times negative 4 is positive 4. Negative 1 squared is positive 1, so that's going to be plus 12. And then plus 5. So I'll have that plus 5 at the end. So then if we think about adding this together, you're going to have 3 plus 4 is 7. Plus 12 is 19, plus 5 is 24. So this is asking us, is this a factor? Well, the theorem says it has to equal 0 when you substitute in for it to be a factor. So the answer is no, x plus 1 is not a factor. Because f of negative 1 did not equal 0. Okay, so our next example, example 4, is a word problem. And it says, the polynomial x to the 3rd plus 9x squared plus 23x plus 15 expresses the volume in cubic inches of a box. So let's stop right there. So volume in cubic inches of a box, and the length is x plus 5 inches. What are the other two dimensions of the box if the width is greater than the height? And I underlined that for you. So if you will recall, the volume is length times width times height. So we know the volume is this polynomial. I know that my length is x plus 5. So if I want to find the width and the height, I would have to divide by the length. So you could do long division, but the first thing I see is that this is in the right form to do synthetic division. So if this is x plus 5, again, you can think about setting that equal to 0. The opposite, negative 5, is going to go in the little box on the outside. Make sure you don't need placeholders. So we have x to the 3rd, x squared, x, and then 15, so you're good to go. Take your coefficients, 1, 9, 23, and 15. First number always comes down, multiply. Always adding down, multiply. And when we do that, we end up with negative 15. So when we add those, you get a remainder of 0. So we're going to create your quadratic. I know it's a quadratic because this started with x to the 3rd. So remember, we dropped down 1 degree. So you have x squared plus 4x plus 3. And this says, what are the other two dimensions? Well, this would give me the width and the height. So now you want to factor, if you can, or use quadratic formula. I'm going to abbreviate. If you can do AC, we definitely want to do that. It's faster. So if you come over to the side and you think 1 times 3 is 3, and I need factors of 3 that add to 4. So that would be 3 and 1. Because A is 1, you can do your shortcut here, so we can factor this into x plus 1, x plus 3. And then you need to go back to this underlined part. The width is greater than the height. Well, x plus 3 is going to be more than x plus 1. So this will be our width, and this will be our height. So there's your two parts. Alright, example 5 says, use synthetic division and the given factor to completely factor this polynomial. So they gave you the polynomial. It does say y equal, that's okay. You're only interested in the polynomial and its factor. So if its factor is x plus 5, we're going to put -5 in the box. So we're going to see if we need placeholders. X to the third, x squared, x, and a constant, so we're good. So you've got 1, 3, -13, -15. Always got to bring the sign with it. Drop the first number down, multiply. Add down, multiply again. And one more time to get -5 times -3 is +15. So our remainder is 0. Completely factor your polynomial. So if this is x to the third, your quotient is going to be x squared minus 2x minus 3, and then we're going to factor. So again, I'm going to see if I can do AC with this. So 1 times -3 is -3. I need factors to be -2. So -3, +1 would be my factors. A is 1, I can do my shortcut, so that's going to be x minus 3, x plus 1. Back up to the question, completely factor. If I multiply these two together, FOIL, distribute, box, whatever method you want, x times x is x squared. That's not what my polynomial started with. The complete factor, remember they gave you the first one, so don't forget that, because your factors should all multiply back to your original polynomial. So there's the complete factored form.